Welcome back. This lesson is on galaxies. And galaxies are hundreds of millions of stars all together. And each of these stars, of course, is made up of the gases that's pulled by gravity. And then each of these stars, even though they're very, very far apart from each other, are all bound together by gravity itself. So you've got stars that kind of grab together and agglutinate into a galaxy, and then you're going to see that even the galaxies, that there are millions of galaxies, each of these will in turn be attracted to each other by gravity as well. So you've got matter that will come into a star, and then the stars will all group into galaxies, and then these galaxies will also form larger groups. The first person to really write about this was not necessarily an astronomer. It was a philosopher, a German philosopher in the 1700s named Immanuel Kant, C-A-N-T, or K-A-N-T. In any case, he assumed that some of the blurry, fuzzy spots that you would see if you were to take a look up at the sky were not stars because they were blurry, they were fuzzy. They must be more than one star, so whole groups of stars together. And a lot of people just made fun of him, and it really wasn't until the 1920s that Edwin Hubble, the Hubble Space Telescope's named after him, was able to actually see that he went to one of the nearest galaxies that we can see, called the Andromeda Galaxy, and I'll show you this in class when we get to Andromeda. One of the stars in Andromeda is actually not a star. It's a fuzzy star that is itself a galaxy of stars, 100 million stars within this area. And so he was able to detect within that fuzz distinct bright stars. And then suddenly now we realize that you have whole groups or islands of these groups of stars, which are galaxies. And these galaxies, as we've been able to take pictures of them and see them in different ways, have different shapes, and we're going to look at the different shapes. So the closest one that we saw was within the Andromeda galaxies. There are others that are close, and then some that are so far away. So let's look at the first one. The first one is a spiral galaxy. The Milky Way, our galaxy, is a spiral galaxy. The Andromeda galaxy that Hubble looked at was also a spiral galaxy. It's not the most abundant that has been found, but it spirals, meaning that it all is in going around the center. So think of the Earth going around its axis, but then revolving around the sun, and then the solar system is now revolving around the center of the Milky Way galaxy. The whole galaxy is spinning, and as it spins, it leaves trails, almost like the bubbles on your cocoa as you stir your cocoa. As you stir it around, you're going to get trails of those bubbles. The stars will move all together in the same way. Okay, so about 30% of the galaxies are spiral galaxies, and this has a very large diameter, if you want to think of it being a cross. So small spiral galaxies, 20,000 light years, okay, and remember 10,000 or 186,000 miles an hour light traveling for a whole year. That would be 1 light year. So 125,000 light years would be a large spiral galaxy. Okay, so numerous stars. And then the example would be our galaxy, the Milky Way. Top picture here is of a spiral galaxy looking from the top, and you see that in the center it's so bright that you even have light pollution there. So most of the stars are going to be in the center of the galaxy, and there is going to be what's called a halo, top and bottom. So if you see a galaxy on the edge, you can see that you're going to see a strip of stars, and then a kind of a dome, top and bottom, is going to be that. In that same picture, there's highlighted that there's a globular cluster, so there's even clusters of these together that we'll talk about later. The bottom picture is of a specific kind of spiral galaxy, to where instead of all the stars kind of swirling around on their own, that there's a center bar that kind of travels around, and that whole bar will kind of go around and around together. So it's very similar to a spiral galaxy. The physics on this is still a little unsure, how that can spin at the same size, at the same proportions, with different stars going at different speeds. It's a little confusing still. The most abundant is the elliptical galaxies. And the elliptical galaxies doesn't have arms, swirling arms, so they're smaller. I guess if they were moving faster, or if there was more stars, it perhaps would become a spiral galaxy. But these are the largest number of galaxies that we can see or detect are elliptical galaxies. And an ellipse, remember, is kind of like an oval, egg-shaped thing. So where you do have gravity going on and movement, but no arms. About 10% are irregular, meaning there's no specific shape that you can do. They just look like clouds of stars. Okay, so you've got mostly young stars that they can detect. Perhaps this is a galaxy that is younger than other galaxies, not sure. But about 10% are called irregular. There's numerous irregular galaxies in our local group of galaxies that are along with the Milky Way, various irregular galaxies in that group of galaxies. So a group of galaxies is called a cluster. So a galactic cluster, just like stars will cluster together, and you'll have stars kind of in a patch, you can have galaxies in a patch. So some that have been detected would contain thousands of galaxies. Ours that would contain the Milky Way, I guess our address, if you want to say, okay, I live here, and this is my street, and this is my town, and this is my country, and then the world, and then the solar system, and then the Milky Way, if you want one more step up, you'd have to go to the local group. It's called the local group, and there's about 28 galaxies in the local group. You've got a few spirals, maybe like 6 spirals, mostly irregular or ellipticals, and then a few irregulars as well. Superclusters would be like great clusters, so very large. And if you think of galaxies swarming together into many, many, many thousands of galaxies, you're talking about the biggest thing known in the universe. This is a Hubble Space Telescope that's aimed at just a small fraction of the sky and looking way beyond the stars in the Milky Way to these various galaxies. And you can see that some of these, which could possibly look like stars, now you realize, no, these are groups of stars, maybe hundreds of millions of stars in each, and you're looking at galaxies. When you think of galaxies as being extremely massive, all the mass of all these stars and their planets and all the space in between, that it's going to exert gravity on each other, then sometimes you can see some very dramatic things go on. Galaxies can have a gravitational effect on other galaxies. Galaxies can swirl around other galaxies. Galaxies can be locked in like a dance between two galaxies, moving each other as they move. You can have collisions where they will essentially merge into one larger galaxy. Imagine spraying off your car as you're washing your car and 2 raindrops merge into one larger raindrop. It would happen that way with stars. As gravity affects them, they can merge together. So 2 galaxies of similar size might pass through one another without merging. That's weird. How does that work? And then sometimes they'll merge together and form something big.